Hi, this is Vinith. Today we're gonna learn basics of Opamp, index, definition of Opamp, terminology, basic block diagram of Opamp, functional block diagram of Opamp, configuration, parameters, modes of operation, packaging. Definition: Opamp is a monolithic, linear, very high gain integrated circuit. Monolithic in the sense entire op-amp circuit will be built on the same die in the sense a piece of semiconductor, and a very high gain. Op-amp is a very high gain, has for example it's a gain of 30 to 40. Integrated circuit is in the form of IC is nothing but integrated circuit, and this is a basic definition of op-amp, and we have to learn few more things to clearly understand about op-amp. Basically, Opamp has high input impedance and very low output impedance. Due to high input impedance, very less amount of current will flow inside the Opamp. Opamp will always focus on negative feedback. And now we'll discuss the terminology of Opamp. And it's a positive supply of the Opamp. And this is the negative supply of the op-amp. Op-amp needs a two supplies to work, and one is plus VCC and minus VE, and plus VCC and minus VE of almost the same value with different signs. And LM741 can take maximum of plus 13 volts and minus 13 volts, and these are the two inputs of the op-amp. Two AC plus DC. AC plus DC in the sense practically no signal contains only AC, and this is a non-inverting terminal. If you give input to the non-inverting terminal, and the output will be of the same pace as the input. If you give input to the inverting terminal, output will be the inversion of the input, and this is the output. Basically, op-amp consists of two input terminals and one output terminal. And now we'll discuss about the basic block diagram of op-amp. And this is a basic block diagram. As I said before, op-amp with two supplies, positive supply, negative supply, and it has two inputs, inverting input and non-inverting input, and a single output. And this is the functional block diagram of op-amp. The internal circuit of op-amp consists of a difference amplifier here, interlevel shifting in the middle, and emitter follower at the end. And difference amplifier contains very high input impedance, and emitter follower contains very low output impedance. And this is the two configuration of op-amp. Entire op-amps will depend upon only two configuration. One is inverting, one is non-inverting. In an inverting configuration, we give input to the inverting terminal, and RF is a feedback resistance. As I said before, op-amp should works on the invert negative feedback, and this is a series input resistance, and it's a V0. And this in non-inverting thing, and as I said before, the feedback should be to the inverting terminal, and this is the feedback resistance, and is a RG, and is a V out and V in. And these are all the parameters of op-amp. Input bias current, output short circuit current, slew rate, and CMRR, PSRR. These are the five main parameters of the op-amp. And the typical value of input bias current is 80. The maximum value of input bias current is 500 nanoampere, and units for the input current is in the form of nanoampere. Output short circuit current. The typical value of the output short circuit current is 25, and there is no maximum value for the output short circuit current. The units are milliampere. And the slew rate of the typical value of a slew rate is 0.5 volt per microsecond, and there is no maximum value of a slew rate. And typical value of CMRR is 95 decibels. CMRR means common mode rejection ratio. The ability of a op-amp to reject common mode signal is called common mode rejection ratio, and typical value of PSSR is 96 dB, and PSSR, the acronym is power supply rejection ratio. Power supply rejection ratio in the sense ability of the op-amp to reject the power supply. And the three modes of operation of op-amp. The first thing is inverting. We give input to the inverting terminal, and where the output is in the form of inversion of input, and non-inverting terminal will be grounded. And voltage gain formula AV equal to minus RF by R1, and RF and R1 should be designed in a way that we get a particular gain. And 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 practically the op-amp will be designed for a particular gain. In the case of inverting, for non-inverting, the voltage gain formula is AV equal to 1 plus R1 by R2. R1 and R2 are the resistances, and in this case the output is in the same phase of input. Voltage follower. In the voltage follower, the basic thing is the gain equal to 1 and V not equal to Vi. Whatever is the input is the output. Uh, Advantages of op-amp. Op-amp is an universal amplifier, which is a voltage comparator, and it's a precision rectifier. It's also used as analog to digital converter. And disadvantage of op-amp. The most op-amp are designed for lower power operation. For higher output is desired than the op-amp specifically designed for that purpose must be seen. Most commercially op-amp shuts off when the load resistance is below a specific value. And now we'll discuss about the packaging. There are three packaging of the op-amp, three types of packaging. One is dual inline package, one is quad dual inline package, and is metal cap package. And LM741 is basically a dual inline package. It's an IC, and is a knob indicator starting pin position, and is a pin 1 2 3 4 5 6 7 8, and the first pin is offset, and 8 pin is offset, and the second pin is inverting input, and third pin is non-inverting input, and the fourth pin is of my supply, my negative supply minus VEE. And VEE in the sense we just consider as a representation. And 61 is the output, and 71 is the plus VCC. And this is the internal circuitry diagram of an 741 op-amp. And see, here is a knob indicates starting position, and is a metal can package of op-amp. It basically contains 10 terminals. There is a gain input, positive input, negative positive input in the sense non-inverting, negative input in the sense inverting, gain, offset trim, feedback out, minus VCC, and output, and is a supply to work this op-amp. And it is inverting terminal, non-inverting terminal, this is inverting terminal. This is output. This is a per round instrumentation amplifier 3360Z. And the last and final packaging of the op-amp quad amplifier dual inline package. LM324 is a quad amplifier dual inline package, and this is the IC, and the internal structure of the IC. And here is a negative input, and is a positive input, and here is a positive input, negative input. This is a plus VCC, and this is minus VEE. And this is all about op-amp.